Okay, hello, I'm Leonardo from Mechatronics 5B class, and in here I'm going to explain my works towards today's task about machine vision. So in here, I've selected the most suitable article for me, and I found it's about 3D lane net end-to-end 3D multiple lane detection. So in here, I'm going to divide it into three major different parts. The first is the big picture. I'll be explaining the general overview about what is 3D lane net, end-to-end 3D multiple lane detection, or the general overview. And then the next, I'll explain the method, what is being implemented, or what is being used to achieve this 3D lane net article, and also about the conclusion, whether is it really useful for the future or we should not expand it more, and etc. So the first is about the big picture of the 3D lane net. So about we all know about what is lane detection, where cars nowadays like Tesla can drive its own to a certain location place by itself without a human driving in it. So in here about this 3D lane net is we are trying to achieve the same results by making every cars can move by its own, by giving the cars direction, what should they go ahead to and what should they not touch or avoid. So in here, if I'm giving a few introduction or a few explanation about the traditional lane detection, where we all know that the first part of this 3D lane net or car vehicle direction is by filtering, image filtering, where like what we learn in machine vision, we are being taught about how to filter or make a certain image become something like filter image, directional filter image, where we make lines like cane programs. We are making the image, we are capturing the outlines of each image, and we are compiling all of those methods as a whole, and then we implement it in a system where that system can guide us or give the exact direction that we wanted by using filtered image. But there's a few problems comes because as we all know that every time we are in a vehicle, when we go to a certain place, the roads that we are heading to is not always flat. There's always vertical lane, left, right, and of course there's some holes that we must avoid in the road. But in older or traditional method, for 3D lane detection, they just make an assumption that all of the lane is flat, all of the lane is in 2D. And in here, what we are trying to achieve it, we wanted to take it into another whole level where we know if there is some slope in the road. And of course, we are using more advanced methods to achieve this. And as you can see in the picture, this is the example of directional filter in 2D lane, where the system is only compiling or make a direction in one way, and by using the assumption of this road is in 2D, not in 3D, where they cannot detect there's a slope that can change the course of the vehicle and etc. And the next is about the most advanced technology about 3D lane is the first is monocular camera, where it being put in front of the vehicle to supervise to take a picture towards the lane, and it's being done in real time, different from the old methods where we put a video to a certain program in PyTorch or any other open source apps or web that can do this lane detection. We are putting camera in real time base, where the camera will detect the direction of the road. This is the most popular method. And then the second is there's also loading pre-map lane, where the lane is already being stored in some data, and we just need to load that data into the vehicle, and the vehicle will do its own thing. Of course, these two both method is very good method, but we are trying to achieve more or greater breakthrough. So that's why many research trying to find more and more breakthrough for this 3D lane direction. And in 3D lane net itself, it provides a full multi-lane representation in 3D world, where if there's a slope, it can detect there's a slope. If the road is not flat, it can detect the road is not flat. And what we are achieving right now, what we are trying to achieve, what we are trying to make a breakthrough is, of course, about the autonomous driving, like as you can see in Tesla, or there's also other car that wanted to implement this technology where the car can move by its own without a people driving in it. So for example, you are in a grocery store and then you wanted that car to fetch you, because as we all know that when we are going to grocery, it's very heavy to bring all of your stuff into the car. But in here, instead, the car is driving it to you, so you don't need to bring all of that heavy stuff to the vehicle. That is what we are trying to achieve in this 3D lane net. And also the multi-lane representation in 3D presentation, where we can detect the slope, as what I've said before. That is what we are trying to achieve. And then the method, what is the method being implemented in this article, is by merging the camera, monocular camera, and of course the loading pre-map data that has been exists in nowadays. So by merging those technology, this technology can be achieved. Like the first is what is the flowchart, or what is going to do first. The first is the monocular camera will take an image first, take a single image, input it in from the camera, and then the next is it will detect the set of center lines and or lane delimiters image from it. And of course, this method is used deep learning, and as we all know that there is many algorithm in deep learning such as CNN or CBN and CBM or RNNS. There's many deep learning algorithm, but in this article we are using CNN. Okay, where CNN is convolutional neural network algorithm. As we all know that the normal deep learning method where there is convolution, there is channel, there is the bias, and etc. That is what we are trying to achieve. Like nowadays technology about deep learning, where facial recognition, autonomous driver, and etc. That kind of stuff. So in conclusion, from me myself, as I read this article, is this technology, this approach, or this technology is something that we can implement. It's worth to expand it in to the next level. So, but it is worth to expand it more. But yeah, from what I see, it's not suited in urban areas where the slope is too much, or it's hard to detect the lane from the road, because in urban areas, like there is no proper lane, and of course there is too much slope. So I'm not sure it can be implemented in there, but for me myself, I hope that it can be achieved in the near or far future, as long as we are persist to expand this technology. And I think that's all for me for this short brief of article, and thank you.